All right, this video we're going to go over the answers to the review questions. So getting ready for our test coming up tomorrow. Basically, if you got all these right, it should give you feedback if you got them right or not. So the ones you got right, you can kind of skip over. But the ones you are not sure of, I definitely would watch this video. Make sure you understand them to be ready for the test. All right, so first one, it's actually kind of an interesting question. I know a guy that's a programmer, and he said they put this on their test to like become a programmer for their company. And it's just, can you get two dice? So basically, we know that dice can be from anywhere from 2 to 12. Like if you got two ones, you'd get 2, and if you got two sixes, you get 12. And so the sort of the trick is like they're not as equally likely, right? Like a 2 and a 12 are really unlikely because there's only one way to get 2, 1, and 1, and there's only one way to get 12, 6, and 6. All right, and the ones in the middle, like 6 and 7 and 8, there's actually a lot more ways to get those, so they need to show up more frequently than like the 2 and the 12 do. Okay, so that's sort of the problem with A, is this will be math.random times 6 will be 0 to 5.99999, and then this int will truncate it, so it'll be 0 to 5, and we take it times 2, so it'll be 0 to 10. So that doesn't even cover all the numbers, and it wouldn't be equally, wouldn't have the right distribution either. The second one tries to fix it by doing 0 to, let's see, 6.99999. So it'd be 0 to 6. When it gets truncated, and times 2 would be 0 to 12. So that's no good either because, we don't want to be 0, right? We can't get a 0 in this case. All right, and then letter C is getting close, I think. So math.random again times 6 would be 0 to 5 once you truncate it. So we're adding to 0 to 5, so that's close. All right, and if you look at E, that's actually going to be the one that works here because that is doing 0 to 5 plus 0 to 5. Okay, we already talked about math.random times 6. Those are 0 to 5s, and then we're adding 2 to that. So we can be anywhere from 0 to 10, but then we're going to add 2 to that to get 2 to 12. Okay, and D is kind of on the right track, but again, this I think would be 0 to 12, and again, we don't want to have a 0. So this one will get us what we want, and they'll be not equally likely, but basically, the way this is set up is it's two different die, right? And so it is actually not going to be distributed equally, and this is going to be rare because you'd have to get 0 and 0 or 5 and 5 to get 2 or 12, right? And then there's more ways, like this one could be a 2 and this one could be a 3, and that would give you a 7. We could get a 4 here and a 1 there, and that would give you a 7. So there's more ways to get 7 than there are 2 and 12, which is the correct way to do two dice. So kind of a complex one, but letter E is right on that. Okay, what is equivalent? So basically it says if x is greater than or equal to 1, we're going to multiply whatever x is by 3. And then after that, if x is greater than 3, then we're going to set it equal to 0. So x is not always going to be 0. Like I think if x started off as, say, I don't know, like -1 or something like that, then it would not get set to 0. So it's not always going to be 0. And then if x is greater than 1, is x going to be 0? So that would kind of make sense. Like if x is greater than 1, so if it was like 1.1, we'd multiply it by 3 to get 3.3, and then it would just get set down to 0. So that's pretty close. If x is exactly equal to 1, yeah, I think this one might work. I'm trying to think if there's any exceptions to that. If x was 1, then it would get multiplied by 3. So if we started with 1, it get multiplied by 3, but then 3 is not greater than 3, so it won't get set back to 0. All right, so I think that's going to work unless I'm missing something. Okay, so I went back and did some more research on this, and it turns out I don't really like this question, to be honest, now that I investigated a little bit more, but I already put it on the assignment, so I guess we'll leave it in there. But basically, B doesn't work because if x is, say, 1, then x ends up being 3 times more than what we started with. So this would need like an else clause that says if x is greater than or equal to 1, set it greater than 1, set it to 0, else x is going to be equal to 3 times x. So this part doesn't account for the situation where like x is 1 and it ends up being 3, right? So it needed that else part. Same thing, these ones don't work because they don't mention the times 3 at all. So I think it ends up being E ends up being our best answer. All right, so for this particular one, I would start with De Morgan. So distribute this. So basically we're going to have A, actually it's not really De Morgan, the more that I think about it. I'm going to keep the and. All I'm going to do is reverse this. So A greater than B, the opposite of that would be B has to be less than or equal to A. All right, that would be the opposite of B being greater than A. It would be less than or equal to A. Okay, and my gut here is that this is never going to be true, but to kind of help make some more sense of it, I'm going to reverse this one and put the A here so that the mouth is still facing A. So now it reads A is less than B and A is greater than or equal to B. And I think that never happens, right? If we just read that to ourselves, A can't be less than B and A can't be greater than or equal to B at the same time. Can't be less than B and greater than or equal to. Those things cannot happen together. So never true is the right answer here. Okay, so we're setting C to be A and B or not A and B. So we want to know, like, when will this turn out to be false? Even though it's a lot of work, I think this is a good one to do build like the statements up. So if we start with the 4 possibilities for A and B, they can both be true. We could have A true, B false, A false, B true, and then both false. All right, and then I'm just going to slowly but surely, I'm going to build this whole statement. So I'm going to do and them together. So A and B, that's only true when they're both true. So everything else is false. Okay, and then to build this statement over here, I need not A first. So I'm going to make not A. So I'm just going to reverse the A column. So reverse all those values. So false, false, true, true. Okay, now I'm going to and them together. So now I'm going to do not A, and I'm going to and that with my B column. So I'm going to do not A and B. So if I and those together, I would have false, false, true, and false. Okay, and then the final thing now is I kind of ran out of space, but I have to OR those two things together. So I'm going to OR these two together. So maybe I'll just write it down here. So true or false is true. False and false is, or false is false. False and true is true. And then the last one, false and false, false or for false is false. If I OR those together, I get true, false, true. Okay, and so it looks like always or never isn't right because it's sometimes true and sometimes false. And so when is it false? Okay, so it's false on the second. So it's false here and let's see, here and here. Okay, so out of my choices, it looks like that's when B is false. So when B is always false, we have it. It's not when A is false, and it's not when they have the same value. It's when B has a false value. So that's, again, a pretty tricky one, but in a moment of desperation, I definitely think these truth tables can help. Okay, so num is an int variable, and so we have to say, like, what describes the result of this. So basically here, this num is going to be positive, right, because it's greater than 0. So that's what is happening on this first check. And then so when num is positive, it'll do another if, And basically this means even, right? So when you divide by 2, the remainder is 0, that's even, right? If you look at some even numbers, when you divide them by 2, the remainder is 0. So basically this could say if even, do that, else, so this must be the odd. So basically if it's positive and even, we're going to print A, and if it's positive and odd, we're going to print B. Okay, and C is kind of tempting here. When it's a positive integer, A is printed, otherwise print B. But I think it's better to say when num is positive, even integer, A is printed, and when num is a positive odd integer, B is printed, otherwise nothing. Right? I think that's better because if it fails this first check, nothing is going to be printed. So I think the best way to describe that is if it's positive and even, A, if it's positive and odd, B, otherwise nothing. Right? So that's a pretty tricky question, but that should be the right answer. Okay, another math.random question. And honestly, what I would do to make this a little more concrete is just pick a number for A, but don't pick like 0 or 1 because those are often special cases. So I'm just going to say like A is 4 and sort of see what happens. So B would become 4, or let's see, this would be math.random would be 0 to 3.99999, right? And then it truncates it. So then it would become a random number truncates it, so it would be 0 to 3. So basically, if I add A to that, that would be 4 to 7. Okay, so it's definitely not what we started with. It's not 4. It's not 8. It is going to be a random number between two numbers, so it doesn't start at 0. It does start at A and then twice A, but it's not inclusive because twice A would be, for me, this would be between 4 and 8, but we can't be 8, so that's no good. So it would be between A, which is 4, and 2 times A minus 1, which would be 7. So that would be, E would be the right response for this one. E is correct. All right, last one has you write some code, and you will have to do the sum on the test. So this is based on a population density. So we just have a variable here, a population density variable, and we don't know what it is, but we know we have to assign the categories based on this. So if it's more than 3,000, it's urban. If it's between 1,000 and 3,000, it is suburban. And then if it's fewer than 1,000, it is rural. Okay, so I'm just going to set up my if. So I'm going to do if our population density, and I would just go with the way it's written. So if it is more than 3,000 people, so I can't be equal to, I got to be greater than 3,000. Okay, then I'm going to system out print. Right, I'm going to system out print urban. Okay, and then I'm going to do else if population density. Okay, so now I need to be between 1,000 and 3,000 inclusive. So basically I know I got to be greater than or equal to 1,000, right? If I'm between 3,000 and 1,000, and then I could put and population density less than or equal to 3,000. That would be a way to say it's between those two inclusive, but I don't really need this less than or equal to 3,000 because if it gets to this else if, it already failed this. So by default, it must be not be greater than 3,000. So I don't even really need this part. So if you want to put it there, you can, but technically you don't even need it because we know it would only get here if it failed on the first one. Okay, and here I would return suburban. Okay, and then everything else I'm going to return. Sorry, this fell off the screen a little bit, but I'm going to system out print rule. Okay, that's it. Thanks for watching. These are pretty tough questions, but they will help you be ready for the test coming up tomorrow. Thanks for watching.